Okay, here's the second page of notes for Unit 6. Not as tough. We're only going to do one thing. We're going to do difference of cubes and sum of cubes. So it's kind of like difference of squares, except there's no such thing as sum of squares, right? So that's a difference. But what's going to happen is if you have, here's going to be the, I don't need that. So if I've got a cubed, something a cubed plus b cubed, or there's our difference of cubes. What is that going to do? Well, we call the acronym SOAP, but I'll get to that in a second. So what happens for the sum of cubes is it'll turn out to be a plus b, and then we'd have a squared minus ab plus b squared. So what that is a and b, each term in the front has to be something that you can take a cube root of. When you take the cube root of it, that would just be the a and the b, right? And it would fit in all of that. So that's the form for the positive, the sum of cubes. Here's how it works for the difference of cubes. A squared plus ab. And it's really not all that different. In fact, it's exactly the same, except it follows a pattern. That pattern we followed is called the SOAP pattern. I'm going to do this like that. So SOAP. So see how we have the first sign is positive in the sum of cubes? So this is positive. Then we have this sign, and this sign. That's what the SOAP is all about. That's just to remember how it works. So it's going to be the same sign, the opposite sign, and the last one's always positive. All right? So this is what we mean here. So we started out with a plus sign. So the first sign is positive. The second one is the opposite of positive. And the last one's always positive. Negative. So same, opposite, always positive. That's how we figure out what signs. It's just a learning cue to kind of remember it. You might just look at it and memorize it and just be fine. But just so you know, it's just something to do. So let's put this into practice. So here we go. X cubed and 64, those are both something that we can take cube roots of. So it'd be like, I like writing it out this way too, just to think. I know it's X is something I can cube. That would give me X cubed. Minus, so it's a difference. And what's the cube root of 64? Well, it's 4. 4 cubed is what I get 64. If that was like 80, that's not a cube root, so I couldn't do it. So now I just got to put it into the form. So it's going to be X minus 4, same side. Then I got X squared, opposite side of then 4 times X, always positive. And now I just got to square 4 and get 16. And that's it. Now that X squared plus 4X plus 16 kind of looks like a perfect square trinomial, doesn't it? But it's not. It didn't double. It's not doubled in the middle. So it's not a perfect square trinomial. You cannot break that down any further. That is prime, okay? Be careful with that. That's an easy mistake to make, all right? Let's go over here. We got a sum of cubes. So I know it's X is going to be cubed plus 2, which is going to be cubed. That's kind of the same way to write it. So X plus 2. I know I'm going to be X squared. Same sign. Oops. Opposite. I'm on the opposite. This was the same. Opposite. So then the 2X plus 2 squared is 4 plus 4 because it's always positive. Okay? Pretty put together pattern. All right? Tell you what, let's take a look at number 3. What do I always look for first every single time? I look for a GCF. Every single time. So is there a GCF in this one? Looks like a 3 to me. 9 doesn't work. It looks like a 3. So we pull out a 3. Let's see. Let's divide these by 3. And 3. So that's going to be 3. And that's going to be 27. 27x cubed minus, let's see, 3 goes into 192, 64 times. Oh, look at that. And 27 is a cube, 64 is a cube. So this is going to be like saying 3. Now we're just going to worry about factoring this part. So that's going to be like saying 3x cubed minus 4 cubed, right? So now let's write it all out. It's going to be 3x minus 4. And then I'm going to have 3x. I got to square that. Opposite sign now. 4 times 3x plus 4 squared. So I wrote that out just to show it. And now let's kind of put it all together. Oh, what did I forget? Don't forget to bring down that 3. That's with us. So the answer is 3x minus 4. 3x squared is going to be 9x squared. 4 times 3 is 12, so 12x plus 16. And again, that's not a perfect square trinomial anymore. All right? I mean, that's kind of it. I don't really have anything else to show you. Always look for that. I know I put a lot of problems here. Let's do another one. Just for giggles, I guess. That one's kind of the same. That one's kind of the same. Some of them get a little bit bigger. Like this one, you kind of watch out for. We'll do one last one. All right. So what is that one? Well, I think this is 5x cubed. And I believe 6 cubed is, for your B, is 216. Nothing to factor out there. All right. So 5x minus 6, same sign. It's going to be 5x. We're going to square that. Plus now 5x times 6. Always positive, 6 squared. So final answer, minus 6, 25x squared plus 30x plus 36. Okay? You know what? I think I am going to leave it there because there's some too. If you have more questions, we can use those other 4 as kind of practice problems to discuss together in class if you have some more questions. The answers are down. Oh, no, they're not here. Never mind. Okay, good. All right. That ends the sum of cubes, difference of cubes.